So when we're measuring and we're mapping the surface of the atmosphere, we're mainly looking at our temperature, our atmospheric pressure, the humidity, and the wind speed and the direction. So these are the same things that our newscasters or the weather people are often mentioning. So what is temperature actually measuring? It's measuring the movement of the air molecules. We call that the kinetic energy of the air molecules. So they're moving around, they're bumping around, and when they bump into you, you feel warm. If they bump in faster to you, then you're going to feel warm. And they bump into the instrument that is used, that is a thermometer. We usually just throw it all together, and we call it a thermometer. A thermometer is going to be measuring that kinetic energy. Okay, it's going to be recording it two different ways. Here in the US, it's going to be in degrees Fahrenheit, and in other parts of the world, it's going to be in degrees Celsius. Now, for our temperature, there are some averages, right? So average room temperature in Fahrenheit is about 72 degrees Fahrenheit. In Celsius, that's going to be around 22 degrees Celsius. Now, if you're going to see a map of equal temperature values, all of the lines of equal value are called isolines. But when you're looking at lines of equal value of temperature, we call those isotherms. Okay, now here is how I remember these guys. I've got a thermometer that's going to be measuring my temperature, and the lines on the maps are isotherms. So it uses that same guy. Okay, so let's talk a little bit about atmospheric pressure. What is it actually measuring? And we could think about it as the force. I almost like to think about it as a way to measure the weight of the air. So the force or the weight of the air. And in this case, I'm going to say on the surface. And the instrument that we use to measure that is, let's look at this. Let's say that this is the barometric pressure. The atmospheric barometric pressure, because there's our bar right there. And we're going to use a barometer or a barometer. Okay. And at sea level, there are some averages that we usually see, but let's talk about how that's measured first. Okay, so for a lot, again, we've got our US measurements, and then we have the rest of the world. So for our US measurements, usually we're going to record that in inches of mercury, and the scientific notation for mercury is going to be Hg. So inches of mercury, or for the rest of the world, it's going to be in millibars. Oh, there it is again, bars. And guess what? These lines of equal pressure are isobars. Good, so inches of mercury or millibars. Now, the average air pressure at sea level, it's going to change based on its elevation, but the average air pressure at sea level is going to be 1,013.25 millibars. And if we were to convert that into inches of mercury, that's going to be 29.92 in inches of Hg. Now, what we need to remember with our air pressure as well, and we're going to come back to this a lot because it's going to be influencing a lot, but sometimes it's going to vary, right? So I talked about how elevation, it will change. So at sea level, those are our values, but it changes all the time. And sometimes there is more force that is coming down, and we refer to that as a high pressure. And other times that force isn't as much. As a matter of fact, sometimes our air is moving upwards and that would be a low pressure. So those pressures, the atmospheric pressure is going to be varying a bit as we move along. High pressure and low pressure. Cool. Let's take a look at our humidity. Humidity is actually measuring the amount of water vapor that is in the air. If you remember, water is found in 3 different phases. It can be a solid, it can be a liquid, and it can be a gas. This water vapor is going to be gas. So I'm going to put a little H2O. All right, the amount of water vapor that is in the air. Okay. And it's usually going to be given as a percentage. We'll talk about that over here with our unit of measurement. Good. So what do we use? 2 different instruments that we can use. We can use a sling psychrometer, a sling psychrometer, psychrometer, if you want. No, usually you don't say the P. Okay. Or a hygrometer. Now, in the video, it had a hygrometer, I think, made out of hair or something spooky like that. No, not usually like that. As a matter of fact, most of these guys are digital. Okay? They're digital instruments that are used to measure that. I think that the videos and how it talks about it and everything else is probably good. But no, really, it's going to be a digital instrument to measure the humidity. Okay, unit of measurement. Now, we could talk about 2 different ways. We could talk about the specific humidity, and we've got another video that talks all about these. The specific humidity is the actual measurable amount of water that is in the air, but usually our weather person is going to be talking about the relative humidity, or the RH, as I like to put that, and that is usually going to be given in a percentage. So how much air the water can hold. Okay, now there are some averages. For example, by the way, usually we don't see humidity maps, so I'm going to use this guy for some others. So what are the norms for this little guy right here? Well, here in Sacramento, we usually have around 65 to 70%. Now, this ranges terribly based on the season, based on, the weather patterns that are coming through. But on average, we have something like that. Compare that to somewhere like New Orleans. And in New Orleans, they're going to be seeing averages like 86 to 99%, right? They're going to have very, very high humidity down in the south. They're right next to a very warm body of water, the Gulf of Mexico, and so their relative humidity is going to be relatively high. Compare that to another place like Las Vegas, okay? Further inland, away from the ocean, high temperatures, and there you're going to see averages around 35%. Okay? So our norms range a lot. It's going to range based on the season, but those are going to be some of those numbers that we start to see. Cool. Let's talk last about wind speed and wind directions. And I debated whether I wanted to have these as 2 separate guys or what we wanted to do. But basically, what we are wanting to measure is the movement of the air. And we're going to be getting into more details about wind and where wind goes and everything else like that. A lot of it has to do with differences in pressure coming from a high going towards a low. However, this movement of air, we want to know how fast, and we want to know which direction. All right. There are 2 different instruments that we're going to be doing, that we're going to be using for this. So to measure the speed, since that's what we have first, the speed is using the little cup thing, little spin around things, and it is an anemometer. Anemometer. The the anemometer, the anemometer, okay, not the no. Okay, the anemometer. Good. That's going to be for measuring our speed. The direction is that cute little thing with the rooster on top of the barn, and that is called a wind vane. Why does the farmer have that wind vane? Well, if you start to pay attention, what you start to see is based on the source of the winds, usually we're going to see a change in weather or different weather patterns coming from different places. Anyway, what is the unit of measurement for this? Again, for that speed, it could be miles per hour. It could be miles per hour. It could be kilometers per hour. It could be in knots. That's going to be a measurement that our mariners will often use. So that's going to be the speed. For the direction, this guy's kind of important. Now, it's going to be our ordinal direction. So it's going to be cardinal direction. Sorry. North, south, east, west. But we always name the winds after the direction that they're blowing from. Okay? So if a wind is coming in from this way, it would be halfway between north and east. So we would call that a northeast wind. Okay. Or if the wind was going to be coming directly this way, then we would call that a south wind. It's always named after its source. Named after source direction. Okay. So it doesn't have to do with where it's going. It always has to do with where it's coming from. Okay, so we're going to have southeast. Notice how I always put the N or the S first. Over here, it's going to be southwest, and over here, it'll be northwest. Okay, you can go in between and say north, northwest, east, northwest, east, southeast, and on and on and on, but we're not going to go for that. So when we're measuring and mapping the surface atmosphere conditions, this is what we are looking for. We are going to be getting into more details for temperature and pressure and wind and humidity, but I did want to go through and talk about all of the different instruments and the way that these guys are measured.